I promised you a separate short video about the idea of restricted choice in bridge. So this is career PowerPoint presentation number 2 for me, and I'm going to walk you through these slides. The presentation is called Choosing Cars Instead of Goats, the Monty Hall Problem and its Bridge Application. Once upon a time, there was a game show called Let's Make a Deal. Monty Hall hosted it. I want to be a game show host really, really badly. One of Monty's favorite games was to have a contestant choose from one of 3 doors which hid a prize. The contestant was entitled to the prize behind the door. 2 doors hid goats. 1 door hid a brand new car. But there was a twist. Say you picked door number 1. To further tease you, Monty would reveal a goat behind one of the doors you didn't choose. At this point, Monty would ask you if you'd like to switch or stick with your initial selection. Well, should you switch? Does it matter? All you ever needed to know about conditional probability. If 2 things need to happen, the chance of them both happening equals the chance of thing 1 happening times the chance of thing 2 happening. Here, thing 1 is the car being behind door 1. Thing 2 is that the host showed us a goat behind door 2. There's 3 possible scenarios. Either the car is behind door 1, or the car is behind door 2, or the car is behind door 3. And in the beginning, a priori, sometimes it's referred to, the odds that the car was behind any of these doors was 1 in 3. But we get new information. Monty shows us a goat behind door number 2. So the second row here where it goes goat, car, goat can't exist anymore. What are the odds that the first row exists, where we've actually selected the door that contains the car? What are the odds that Monty would show us door number 2? Well, they're 1 in 2. There were goats behind doors 2 and 3, and he could have shown us either. What are the odds that row number 3 existed? That it went goat, goat, car? Well, Monty would have been forced into showing us door number 2 because he's only got 1 goat left. Restricted choice. When our door contained a goat, Monty's choice was restricted. There was only 1 goat left to tempt us with. But when our door contained a car, Monty had 2 equally attractive goats to show us. He could choose them randomly and would only show us door 2 half the time. Lesson being, it's more likely Monty had no choice than that he did, and he chose door 2 to show us. If it's more likely Monty had no choice, we should switch doors. And if you look at our previous slide, given what we know now, the chances that it actually is car, goat, goat is 1 in 6 of the original possibilities. The chances that the car is hanging out behind door number 3, that's row 3, is now 1 in 3. All of the initial possibilities of the car being behind door 3 still exist, whereas only half of the possibilities that we originally made the correct choice still exist. Enough with goats and cars. How am I ever going to use this? Well, it turns out that Monty likes to make guest appearances at the bridge table. If you have a suit of Ace King 10 6th facing dummies 3 small, and lead the ace, your left-hand opponent holding Queen Jack Doubleton has a choice. He could play the queen, or he could play the jack. He could show you either of 2 goats. An opponent holding Jack Singleton has no choice. His choice is restricted. He must play the jack. The odds favor that what is actually going on is that your opponent had no choice, not that he had one and selected a particular option. 1 prayer is easier to answer than 2. Back to the bridge table. What you should now do with this suit is finesse your right-hand opponent for an original holding of Queen Third, expecting it to win roughly 65% of the time. This has been about goats and cars and the Monty Hall problem and restricted choice and how you should play when your left-hand opponent drops the jack under your ace. Hope you enjoyed it.